Hello all, today we are solving LeetCode problem number 1888, minimum number of flips to make binary string alternating. So what exactly mean by alternative string? So a string is said to be an alternative string if it has alternative bits appeared in the string. So which means either it should when it starts with 1, it should be 10 10 10 and 10 so far, and when it starts with 0 it should be 01 01 01 and so on. So this is what is meant by alternating string. So you are given a binary string s. You are allowed to perform two types of operations on the string in any sequence. So we are given two operations which can be done in any sequence. So type 1 is remove the character at the start of the string s and append it to the end of the string, so which is nothing but basically rotation. So you take from start of the string and you put it down in the end, and this is the left rotation. So this is one type of operation, and when you see the second type, pick any character in s and flip its value. That is, its value is 0, it becomes 1. So it's basically flipping. So if it is 0, it becomes 1. If it is 1, it becomes 0. So these are all the two operations available, and return the minimum number of type 2 operations. So there is no cost for type 1 operation. So return the number of type 2 minimum number of type 2 operations you need to perform such that s become alternating. So they have given an example for this. This is an alternative string, and so is this, but this is not. So how do we solve the problem? Basically we are given an example, and I'm having an approach of approaching this problem to solve it. So we have 1 1 1 0 0 0. So for this I'm using the first example. So we know that based on type 2, when we are flipping using this flipping operations, it is either gonna be 10 10 and so on, so, or it is going to be 01 01 and so on. So for getting these two alternate type of alternative string, we will be performing flipping operation, and minimum among uh, uh, 10s and 01s conversion will be the total number of type 2 operations to convert into a alternative bit. So oops, this is minimum. So this is the first observation, and when you are looking into the type 1, it is simply 1 1 1 0 0 0. It turns out to be 1 1 0 0 0 1. So at this case, when you are looking at it based on this rotation, we have got this particular value based on using one type 1 rotation, and from this converting into a alternative string is pretty much easy, because just convert this to 0 and followed by convert this to, or flip this to 1. Flip will be the actual word to use, so which will result in 1 0. Oops, this should be not, this should be, this should be 0, then this should be 1. Oops, this should be 1, and this should be 0, and this should be 1 and 0. So this cost us 4 operations. So in that case, let us look here. When we are converting this to 0 and this to 1, I think we are getting alternative the alternative strings, which is 10 10 10, and it cost us 2 operations. So you can see the difference, right? When we are rotating, it becomes costlier, and when we are not rotating, it is not cost, I mean cost minimum. It is a minimum cost or minimum number of operations. You can have it whatever you can. So So in this case, you cannot come into a direct conclusion that keeping the string same without doing any type 1 operation will be is ineffective. But in this case, this is ineffective, not in all case. So what you have to do is you have to calculate this and this simultaneously, meaning you have the string 111,000, calculate type 2, and you rotate it, so 110,001, and then you calculate type 2. So you can repeat the same thing, and then you will be having uh, the minimum number of operations required, because you can use minimum function to have the minimum operations for conversion. But in this case also, for type 2 you have two types, which is 10 and 01. So you have to track down these two as well. So this is the overall idea. So to efficiently solve this, because this approach whichever we have discussed so far, it will cost us a lot of functions, nested functions writing within it. So instead of that, what can be done is having uh, performing this left shift or left rotate to perform these operations. You can have it as one double the string actually, so which is nothing but string is equal to s plus s. So based on that example, you have 111,000 and 111,000. So now how this is going to help when we are rotating it, you know that this string will be taken and this will be append in the last, right? So basically we have initially this as the window of length n, and next what happens is the length the window becomes, this will be removed and it becomes this, which is 110,001. And what happens here is again this one will be taken and append in the last, so hence this will be removed and the window extends right towards the right. So similarly you remove this and you can extend it. So this makes us one job easier. Along with that, you have to track down using the two type of alternatives, which is alt 1, alt 2. So this is 010101 followed by 010101 and 1010101010. Yes, so you have these things created based on the iteration and the values you create all these. Now what you do is you have a window range which is of something like this or something like this, yes, of length n, and now you have flip 1 and flip 2, which will store the maximum or the minimum flips to form this alternative 1 and this alternative 2 values. So we will use this window, for example 111,000. So based on this first flip, you have to get this one, you have to convert this into 0, this becomes 0, this becomes 0, and what else, this become 1, this become 1, so this cost us 4, and similarly this will cost us 0 0 1, yes, this will cost us 2. So this is type 2 and type 2, so this will cost us this. And what we will do next is we will shift the window right. So we have left pointer here and right pointer here. So when we shift this, this will be initialized to 0 and this get updated to 1, and so does this not exactly this, because we will store the right value to be the I plus plus length of yes. So based on this, not exactly I, this should be L. So based on left, this determining this right pointer varies because that is what determines the window. So we will calculate each and every flips based on this window, and we will have the minimum value stored using a minimum function, through which we will have uh, the flip 1, flip 2. Along with that, based on this type 1 operation, what we do is whenever we are removing this, right, so we can see here 1 is not same as this 0. So based on that, you can decrement whatever flip value is here by 1, and when the new window comes in, you can see here 1 and 0 are different, and because of that you can increment the count by 1. So this stays as 4 at the next window. So we will do this repeated addition, repeated steps to solve this problem. So to be very clear in this, I will mention the operations. So what we will do is, if we will use alternative 1, so alternative 1 of I is not equal to yes of I, you increment flip 1 plus increment by 1. Similarly for alternative string 2. Okay, so this is part 1, and what we do next is, when we are coming into the window, we will check again alternative of left. If it is not equal to string of left, then what happens here is you decrement the flip 1 by flip 1 decrement by 1, because we are moving with a window, right? So it is due to this reason we will be decrementing it. And what happens is we should this will be repeated for alternative 2 as well. So because of that, we are resulting in the operation of flip 2 decrementing by 1. So when we are done with complete window, we will have the minimum value stored in the result basically. So this is how we are going to solve this problem. So with this idea in mind, let me jump into the code. So we start with length of yes, which we are storing in n, and we will have s updated to s concatenated with s. So you have the double of the string, and now you have alternative. You need to create an empty string for alternative 1 and alternative 2, which will have the 0 1 0 1 as the starting, and 1 as 1 0 as one more pair of alternative bits. So you have alternative 1 is equal to empty string, alternative 2 is also equal to empty string. So we have to fill in, because we need to based on the n value, we have to generate the alternative binary string which could be formed, and we will be storing that in the alternative 1 and alternative 2 to use it for the calculation purpose. So for I in range, you have length of yes, because you will be storing double of the again similarly, since you have concatenated yes, you will have generate the alternative string double the time, which is of size this updated yes to be correct. So now alternative 1 will be equal to, now this will be plus or equal to 1 if I modulo 2 is true, which is nothing but if it is 1, so else 0. And alternative 2 plus or equal to, this will be 0 if I modulo 2, and else will be 1. So now that we have generated the alternative 1 and alternative 2, now we have to have result which is equal to float and infinity value, positive infinity, because we need to get the minimum number of flips, right? So flip 1 is equal to 0, flip 2 is equal to 0. Oops. And we have for window, I mean using this sliding window, we need the left pointer, so which is initially 0. So with that we can jump into the pointer part. So for right in range length of yes, and here if yes of right is not equal to alternative 1 of right. So in this case what you does is, since it is not equal, this is for the this type 2 operation, so we're using which you calculate the number of flips. So flip 1 is incremented by 1, and if yes of right is again not equal to alternative of 2 right, in this case as well you will increment the flip 2 is getting incremented by 1. Yes, by 1. So now that we have done with this part, now we have to use the window, and we have to do the next operation, which is nothing but based on the window. When we move it or when we rotate it, when the number matches, we will be we can reduce the flip, right? Because that will reduce the type 2 operation, and due to that we will be getting the minimum number of flips required. So since that we have calculated the flip actual number of operations which is being counted by type 2, now we have to reduce it, because we will be performing as much as of operation this to reduce the number of flips. So in that case, if right minus left plus 1 is greater than we have n, yes, n. So this is as per the observation which I have shown you during the dry run time. So based on this, if yes of right is not equal to alternative 1 of right, so in this case what will be done is flip 1 is reduced by 1. So again this should be not right, this should be left actually, because of the left shift, I mean not left shift, to the rotation we are doing. So if yes of left is not equal to alternative 2 of left, in this case flip 2 is again reduced by -1. Yes, and we will be incrementing the left, moving on to the next element, incrementing the left pointer. And this, since this is done, now the last part, if right minus left plus 1 is equal to n, in this case what is done is result is equal to minimum, because we are done with the rotation, and of the result value whichever is being stored here, and flip 1 flip 2. So based on this we are done, we will return result, and there you go. Let me run it and submit it. Thank you.